Hello everyone, today we'll be solving the problem number 46, permutations. So you can just go through the question and try to understand the question with the help of examples that they have given. So what the question states here, I'll just summarize the question so that it will be easier to understand. So what the question states here, we are given an array nums, you can clearly see here, we are given an array nums consisting of distinct integers. So array nums consists of distinct integers. Will not be having the duplicate numbers, right? So array nums consisting of distinct integers. What is our main task then? Our main task is to generate all possible permutations of the given numbers. We have to generate all the possible permutations of the given numbers and return them in any order. Order doesn't matter. We can return in any order, but we have to generate all the possible permutations of the given numbers. So that's what they have asked us to do. Here you can just see here nums they have given 1, 2, 3. All the possible permutations of number 1, 2, 3 they have given as output. Here you can clearly see 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2 and 3, 2, 1. 6 this one we have, right? 6 possible permutations we have. All of them they have mentioned here. We have to mention within the array, right? So here they have given in the second example 0, 1, 0, 1 and 1, 0 are the permutations or the possible permutations, right? Here we have only one element here, so we will be having only one permutation here in this case, right? So I hope the question is completely clear what we have to do. So initially let's discuss the approach followed by edge cases and then finally write the code and discuss the complexities of the code that we have written. Initially, as usual, let's discuss the approach. So here let's discuss the approach step by step. First thing we have to keep in mind here is we will be making use of the backtracking or recursive backtracking to generate the permutations. So what is the main idea behind using the backtracking here or the recursive backtracking? The idea is to swap elements to generate different sequences and finally revert the swap to explore the other possibilities. So just keep in mind that we'll be going with the backtracking. Here the first step is to understand the permutations generation. So how we generate the permutations, that we have to understand, right? First we fix the first number. We fix the first number and recursively generate the permutations for the rest. That's what we will do. Then we will swap the first number with each number one by one and we will repeat the process, right? So first what we will do, we will fix the first number. Here in this case, let me give, first we fix the first number and recursively generate permutations and recursively generate permutations, right? This is the first step. So then we swap the first number with each other number one by one. So what we'll be doing here, we swap the first number, one by this one, we swap the first number with each other number one by one, each other number one by one. So that's what we'll do and we will be repeating the process for all the numbers. So after swapping we will just backtrack. So this is what we will do. So this will be the approach. First thing is we will fix the first number and recursively generate permutations for the rest. Then we will swap the first number with each number one by one and we will repeat the process. After swapping, we will backtrack by swapping back to restore the original array. So that's what we'll be doing here. So let's see the recursive backtracking here, right? So let's consider this example. The example that they have given in the question, they have given here nums 1, 2, 3, right? And they have provided all the possible permutations. So let's see this one step by step accordingly with the approach so that we understand this one clearly. So here what we need to do, we need to generate all the permutations for the array 1, 2, 3, array containing the elements 1, 2, 3, right? So we'll be making use of backtracking as we have discussed. We'll just swap the elements to explore all the positive order. So let's go with the step 1 here. So this is first example they have given in the question. So first step is here, start with s equals 0. We'll be starting with s equals 0. Nothing but first element fixed, swap with itself and others. So we are swapping 1 with 1. Now it will be 1, 2, 3. When we swap 1 with 1, it will be 1, 2, 3, right? So then we will move to s equals 1. Next, we will swap 1 with 2. Now it will be 2, 1, 3. We are swapping 1 with 2. Now it will be 2, 1, 3. Now we will move to s equals 1. Finally, we will swap 1 with 3. Now it will be 3, 2, 1. Again, we will move to s equals 1. This is for when s equals 0. Nothing but first element fixed, swap with itself and others. This is for the first step, right? So let's move on with the second step. I'll just come here. This is step 2. We have to move to s equals 1. When I say s equals 1, here second element fixed, swap with itself and others. Starting, we will start from 1, 2, 3 here. Again, similar to the previous step. So here from 1, 2, 3. This is for the first one. Within the second step from 1, 2, 3. We will swap 2 with 2 here in this case. So now it will be 1, 2, 3. And we will move to s equals 2. Second step is we will swap 2 with 3 here. In this case 1, 3, 2. Again we'll move to s equals 2. This is for from 1, 2, 3. Next step it will be from 2, 1, 3. Right? We have to consider 2, 1, 3. So in this case we will swap 1 with 1. Again we will start from the beginning, right? We will swap 1 with 1 here. So this will be same. 1 with 1 means 2, 1, 3 itself. We are just swapping 1 with 1. This remains 2, 1, 3 itself. Next we will swap 2 with 1. This will be 1, 2 with 1, right? We are swapping 2 with 1. This will be 2. Sorry, just give me a second here. What we are doing here? Yeah, we are swapping. In this case, we are considering 2 and 3 here, right? So we are swapping 1 with 3. Sorry, in this step, I got confused here. We are swapping 1 with 3 here. This will be 2, 3, 1. So we'll be moving to, this is second step, we'll be moving to s equals 2, right? In this step. So within the second step, the third main thing here is from 3 to 1 we have to consider here. From 3 to 1 here, right? So just give me a second here. Why we are considering from 1 to 3, from 2, 1, 3 and from 3 to 1? In the previous step we have got the same thing here, from 1 to 3, 2, 1, 3, 3 to 1. When we considered s equals 0 and we moved to s equals 1, we are considering this one now. When s equals 1, right? When s equals 2 here in this step. I mean, yeah, sorry, when s equals 1. Sorry, I got confused here. From 1 to 3, from 2, 1, 3, and this one from 3 to 1 we have to consider now. This idea is basically completely dependent on the swapping, right? So here from 3 to 1 we swap 2 with 2. This remains 3 to 1 itself, and we will move to s equals 2. Then we will swap 2 with 1. So this will be 3, 1, 2. We will be moving to when s equals 2. So this is it. These three we considered, right? Now we have to move to s equals 2. This is the third step basically. And s equals 2 means last element is fixed finally. We have to add to the result. So last element fixed. This is the last element, right? If you consider here, you can clearly see 3. This is the last element, and here last element fixed, we have to add to the result. So when I say we have to add to the result, we are adding, first thing will be 1, 2, 3. Here you can clearly see 1, 2, 3, 1, 3, 2, 2, 1, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 2, 1, and finally 3, 1, 2. So last element is fixed. So we are just adding it to the result, right? So the final output will be here. In this case, what we got here, 1, 2, 3 is one thing, and 1, 3, 2 another thing. So 2, 1, 3 another possible permutation. 2, 3, 1, this is one more possible permutation. 3, 2, 1, and finally 3, 1, 2. This is fine. This is the output that we got, which completely matches with the output they have given in the output they have given in the example. You can just check it. The same thing. So approach works absolutely correct in this case. We are going with the recursive backtracking, right? So I hope the approach is completely clear. Next, let's discuss the edge cases one by one and then finally write the code. You can just try it out for the second example they have given in the same way that I have showed you for the first example. You'll get all the possible combinations, right? So that you'll understand the approach correctly. It will be easier to write the code when you understand the approach and run the example that they have given initially accordingly with the approach. And then when you consider all the edge cases, finally it will be really easy to write the code. So now let's discuss the edge cases one by one. So let's discuss the edge cases one by one. First edge case I'll be discussing here as minimum. Let's consider here minimum input. So when I say minimum input, let me consider here input 1, right? So we are having only one element. The possible permutation here will be 1 itself because we have only one element, right? So this is for the condition minimum input. So next, let's consider for the 2 elements. We are considering for the condition 2 elements. Let me go with 0, 1 in the input. Output will be 0, 1 and 1, 0, right? This will be the output. Let's move on with the so these are the possible permutations for the 2 elements, right? The example that we have considered. Here let's move on with the third edge case, nothing but 3 elements. 3 elements we have already seen that one, the example that we considered, right? So we dry run the example accordingly with the approach. The same thing, let me consider here one more time. I don't have to write this one, right? All the 6 permutations. Same thing, first example we discussed, right? That they have given in the question. So output will be all the 6 permutations, right? So I hope this is clear. So this is for the condition 3 elements. Let's move on with the final edge case or the fourth edge case, negative numbers. When I say negative numbers, we have to consider negative numbers, right? I'll just consider here -1, 0, 2 here. So here the output involves negative permutations. Negative permutations here, right? These are the edge cases that we need to consider. So for this one, you can just if you want the permutations to be shown, you can just try it out in your in the same way that I had showed for the example one. For this one and this one, for this one I had showed, right, earlier. So you can try it out in the same way for this one. You will get all the permutations here. So these are the 4 edge cases that we need to keep in mind. One is minimum input. Second one was for this one, 2 elements. Third one was for 3 elements. Fourth one was for negative numbers. I hope all the edge cases are clear. Now let's start writing the code. So let's write the code. Initially, as we had discussed in the approach, we have to store the results, right? And we need the array length here. So for storing results, let me give here, initialize the result to empty array initially. And this one, array length, I'm just considering the array length here. This will be nums dot length. I'll just consider for the n, right? So next, let's go with the recursive function for backtracking. So I'll consider here recursive function backtrack. I have to consider, right? I'll just give the name backtrack here. Let me pass the parameter s here. So I hope this is clear what we are doing here. Base case, we have discussed this one. We have to add the initial permutation, right? So if this is simple if condition, if s equals n, then we have to return result dot push of what is the parameter we have, nums, right? So this is nothing but we are adding permutation. This is the base case. We know this, right? Next, let's iterate. So I'll just give here I equals 0. We are iterating through the each number. So here we have to swap the current index with I. So again I'm telling we have to swap, or we are swapping the current index with iterated value or I. So here I can write in this way, nums of s, nums of I. This will be, we are just swapping here. So I'll just consider here this one in this case. So again, so let me consider here this one. Let me copy this one here. This is fine. What we are doing here, we are swapping the current index with I. I hope this is clear. Next, we have to recursively generate all the permutations. So let's make use of the here recursive function name. We have to recursively generate all the permutations, right? So here let me give s plus 1, right? So this is, I hope this is fine. Next step is backtrack, or we have to swap back. This one we have seen in the example, first example that we considered there. We have to swap back, right? Every step. So how can I write that one? So I can just give here the same step here. Let me copy paste the same line here. This is same as the line number 7. Line number 10 is same as line number 8. Sorry. Yeah. We are just backtracking here, or we are just swapping back, right? Here in the line number 8, what we are doing, we are swapping current index with 1. In the line number 10, we are backtracking, or we are swapping back, right? I hope this is clear. So after this step, we have to start the recursion from index 0, right? So I'll just come out of this one, come out of the function, backtrack function, and we have to start the recursion from the first index, or index 0. So simple here, backtrack the function we are considering, right? This one, backtrack from the index 0 we are starting. So I'll give 0 here in this case, and we need to return final list of all the permutations that we got. So for that one we have considered here result variable, right, initially. So let's return here result. So let me format this one once, and let me hit the run button. So we are getting wrong answer here. What we are getting here? So 1, 2, 3, we are getting only 3 possible permutations. We have to get 6 possible permutations, right? Or 6 permutations here. What's wrong here? Let's check what is wrong. So what mistake I have done here is in the line number 7. So we have the parameter s here. So we have to consider here I equals s, right? Not I equals 0. So this I have considered wrong. So let me format this one again, and let me hit the run button. So again we are getting wrong. So what's wrong now? So in the same line, in the line number 7, I forgot to give let here. Again, this one. This is fine. I had forgot to give let, and I had initialized I to 0 instead of s here, right? So these were the mistakes, typos. Sorry. Let me run this one again. So now you can clearly see the sample test cases are getting passed here. So let me hit the submit button now. So you can clearly see all the test cases are getting passed here. So the code works absolutely correct. So let's quickly discuss the time complexity and the space complexity of the code that we have written. So first thing, we know that the approach that we went with here is recursive backtracking, or you can just call it as backtracking, right? So what will be the time complexity here? The overall time complexity would be here big O of n factorial. Why it is big O of n factorial? Because factorial growth here is due to the permutations, right? So it is big O of n factorial. Then what would be the space complexity then? The space complexity would be here big O of n factorial as well, because we have to store all the permutations, means we have to display all the permutations in the form of output, right? Then in that case we have to store all the permutations as well. So the space complexity would be big O of n factorial as well in this case. I hope the time complexity and space complexity is completely clear, right? So time complexity and the space complexity of the code that we have written as big O of n factorial. I hope the solution is also completely clear. For now, this is it. Thanks for watching, guys.